Hi. Thank you, everyone, for coming today. We're here today to talk about managed Kubernetes services in the enterprise. As a brief introduction, my name is Daniel Selman, and I'm a Kubernetes consultant with Microsoft Consulting Services, MCS, where I work on both POCs, workshops, and production migrations for Kubernetes workloads to Azure.
And just like Daniel, my name is Sujit. I'm also in the same group as he is. I'm also in Microsoft Consulting Services. I focus a little more on app dev side of things as opposed to Daniel, who's more on the infrastructure. And of course, nowadays, Kubernetes is a big thing with our customers. We've had the fortune to work with a lot of enterprise customers on Kubernetes deployments. And so what we've tried to do is to take some of the best practices that we've understood from those engagements and present it to you guys so you can reap some of those benefits.
Yeah, to set the stage, essentially, enterprises are beginning to more and more move over to PaaS services or managed services. However, oftentimes they want to still apply their existing requirements for infrastructure hardening even on these managed services. And so essentially they want to have their cake and eat it too. So what we're going to discuss is ways to apply traditional enterprise requirements in a Kubernetes way, that is using the native API scalable solutions. Additionally, we're going to show how to do this in order to meet some of those traditional Linux requirements.
I want to just quick show of hands. How many of you over here have installed the Kubernetes cluster by hand?
Everyone. Awesome.
Oh, a lot of you. So we're not going to talk about that kind of stuff. We're going to talk about the PaaS offering where a cloud vendor like Amazon or Google or Azure will offer you a Kubernetes service as a PaaS offering. Because that's where we see customers are going towards, the managed Kubernetes offering. And how you can take that and still meet some of the requirements that these customers have.
Yeah, so in terms of the topics that we're going to cover today, first and foremost, security is always top of mind with enterprises. And so we're going to go through different types of business use cases and how to establish solutions for them in a Kubernetes native way. Additionally, monitoring is always top of mind, so we'll be discussing fundamental approaches to monitoring. After that, we'll discuss some of the synergy that comes with managed solutions across the technology stack, some additional advanced topics, and then demos. So in terms of security, there are very common business use cases that apply across enterprises regardless of the industry. These include restricting the attack surface of the cluster, configuring machines based off of existing security requirements, securing connections to on-prem resources, ensuring all cluster egress follows regulatory and compliance requirements, and then finally, enforcing secure communication between all application components. What we're going to do is dive into each one of these and introduce not a comprehensive, but rather a set of potential solutions to do these in a Kubernetes way. So first topic is reducing the attack surface area. We're going to talk about two different approaches for this. First, companies don't want to have anonymous access to their cluster. Outside of just the CVE that was announced last week when it came to anonymous access, you still also don't want to expose your cluster publicly to the internet or your application publicly to the internet. So you can get around that using internal load balancers. Additionally, for people that are authorized to use the cluster, there's also a consideration that you don't want someone to be able to delete, let's say, your production workloads. In those situations, you'll want to control users' permissions even when they are authorized using native Kubernetes RBAC. So briefly to touch on it, when it comes to an internal load balancer, they're pretty straightforward. Essentially, all you do is you define a load balancer just as you would the internal load balancer just as you would any typical load balancer, and then provide some sort of flag for the cloud provider that you're on. This example here is in the annotation space is an example of how easy it is to set a ILB within Azure. What this then does is it provides an internal IP address in terms of the actual resource that's created, so it's not publicly exposed to the internet. But also, from a Kubernetes standpoint, it still views it as an external IP address, just as it would, any load balancer that's created. Next, in terms of RBAC, there are two real topics here: the cluster role and the role binding. When it comes to cluster role, essentially what this is it's defining a class of roles, and then it sets what resources they have permissions for and explicitly how they have access to those sort of permissions. So an example here is the pod reader. They have access to get, watch, and list pods, but it doesn't mean that that new hire can delete that production workload. And so in order for these are namespace agnostic resources, meaning that they can be applied in many different contexts. That's where the role binding comes in. So what the role binding does is it takes this class and applies it in a particular namespace to a particular resource. So what we're defining here is me. I am the user, Daniel. We're setting RBAC authorization for the pod reader role, and that's in the default namespace, meaning that once this cluster role is applied, I have the access to get, watch, and list pods, but no actual edit or delete functionality, for example. All right. The second topic in terms of security is configuring machines based off of existing security standards. Oftentimes, enterprises have hardened standards for Linux machines that they want to apply across the board, even in managed services like AKS or general managed Kubernetes. This is augmented by the fact that when you go into the portal, you can see in the managed resource group that there are actual VMs sitting there, meaning that raises some alarms when it comes to security teams wanting to get more hands-on with actual hardware there. But there's an issue. You can't SSH, you don't have access to the machines in the traditional context. SSHing into all of the Linux machines, isn't scalable because you have things like cluster auto-scaling in terms of the nodes, meaning that you would have to constantly reapply. And also, it's a wasted effort because you can do so. You can do these customizations through the Kubernetes native API. So what we're going to discuss is a solution to apply some sort of custom system hardening using Kubernetes native functionality even in the managed service. The for example here is an anti-malware daemon set. So the solution design has 3 premises. First, as some of you are likely familiar, daemon sets can create a pod on each worker node in the cluster. This is great because it provides a scalable solution even when our cluster expands and contracts. The second premise is that pods can mount volumes on the underlying node using the host path parameter for a volume. What this means then is that we have access to the files on the underlying VM. This is great in Linux environments because, as you know, everything's a file, which makes things very, very convenient. The third premise is that the init.d directory in etc on the node tells the node what programs need to be run. Therefore, in order to customize the ultimate software running on the node, you'll create a daemon set mounting a particular directory. This example just mounts root on the node, copies a program, and then modifies initd in order to install and run it. This is useful for other utilities as well that aren't easily deployed using a container. We're just using anti-malware as a common use case. One word of caution, though, this should only be used in situations where it's absolutely necessary in like a go, no-go situation. Generally speaking, you don't want to be mucking around too much with the underlying nodes given the distributed nature of Kubernetes. However, in situations where it's absolutely necessary, this provides you a way to ensure consistency across all worker nodes.
Yeah, I just want to mention something, that typically when the cloud vendor puts up these nodes, they make sure that the nodes are patched, and so there's a certain security that comes along with it. So, you don't want to go overboard with this kind of solution, but there are some customers that really want to have some presence on the nodes, and this is the way to do it.
So, in terms of this, the real bulk of the value comes from the args parameter here. Essentially, what we're doing is we're changing the root of the underlying container to the node root. And then we're setting the security context as privileged, meaning that it provides it permissions to alter things on the underlying node. Then what we're running is just a simple apt-get update and everyone's favorite anti-malware, ClamAV. But just a simple example of a software that we're installing that then updates initd, it installs the application in etc in order to ensure that it's running on the underlying node. You'll notice that we have this while true do sleep 30 done. That's something you'll often see when you're running administrative daemon sets or just administrative tools because pods exist to run a job. So if the job is complete, then the pod will terminate. This means that the daemon set will be in a state of, it'll be spinning down, spinning it back up, spinning down, spinning it back up. So you need something to ensure that it has some sort of function outside of just an administrative boundary.
Yeah, let me talk about connections to on-premises resources. So one thing that all enterprises have is they don't exist fully in the cloud. There's always an on-premises data center, could be with your own cloud own data center provider. And then, of course, they're moving, either in the process of moving things to the cloud, or they have both at the same time. And so typically, you're going to get in a situation where you're going to have a virtual connection, a virtual circuit, so to speak, between your cloud provider and the on-prem system. And when you install Kubernetes, it is possible to set up, go ahead, yeah. So yeah, you could, when you create the virtual network in which the Kubernetes cluster is deployed, you can connect that virtual cluster, that virtual network to the circuit that is connected to the on-prem system. And that's just part of the configuration of a managed Kubernetes service. It's there. You don't have to muck around with the actual VNet, go and do any special commands outside of the scope of the managed Kubernetes service. You can do this right out of the box.
Yeah, the big takeaway here is really when it comes to enterprises, there are always going to be legacy systems for most cases, in which case peering the VNet gives you the ability to securely access resources on-prem to deal with those legacy requirements that might not be same consideration when it comes to like startups, for example.
Yeah, and once this is connected, all the pods are going to see all those on-prem systems, so that's the beauty of it. Well, the other thing is egress. Now, we talked about how these clusters are locked down and don't have access to the internet, but at the same time, sometimes you need to get out of the internet, for example, to look up a CRL revocation list or call some external web service that you subscribe to. So how do you do that? So typically, customers would want to do it through a proxy server. And so you have to force all the applications to route traffic through the proxy server. And one way that we've done it is to set the environment variables, which is HTTP proxy, HTTPS proxy. You can set these as part of your startup script in the application so that every application has no option but to use the proxy server to go out when it has to do egress. And this way, and part of the reason, of course, for this is to also maintain compliance and for some of these customers that want to make sure that the data that's going out to the internet doesn't contain any PII or anything inadvertently leaked.
All right, the final topic on security we're going to cover is enforcing secure communications between all application components. The way we're going to approach this is a ground-up solution, given that oftentimes when it comes to enterprises, they want to be able to build their solution internally rather than maybe leveraging some of the more open source technology. And so in this case, we're going to walk through a solution where we install custom certificates as part of an application bootstrapping process and then enforce TLS via an app config. So that means that there are two parts here. The first is how do we get the certificate onto the container when we run these containers. And the second part is how do we enforce the application to always use this TLS standard. So we briefly talked about it there. There's an additional concern, which is that enterprises also usually use their own CA. And so it's very important that they have specific certificates that they use in these situations. Essentially, what you'll do is you'll use a startup script. Essentially, you'll put the certificate in some sort of cloud store, whether that be something like Azure Key Vault or even just a file share. And then you'll create a script that runs in the container when it's initially booted up that will pull the certificate from the cloud storage and then run some steps to install it on the container. When it comes to enforcing the application to use TLS, we have an example. However, the enforcement is oftentimes framework specific, but usually it's just setting some sort of TLS enforcement, as we see here.
Yeah, so here's an example using ASP.NET Core where you can force that the traffic that you're accepting is only TLS 1.1 or 1.2, depending on your standards. But this is something that has to be integrated into your own application. There is no way to tell for a Linux to configure Linux to only accept a particular protocol. That's something done at the application level. So if you have PHP or Java or any other language, that's what you have to do it.
And then same when it comes to certificates. Essentially what you'll do is just run an install to ensure that you have all the cert utils, copy the certificate to the right location on the underlying container, and then just run an update CA certificates. What we found is that doing this at runtime doesn't really impact performance from any sort of logical or from any sort of impact standpoint. And if there is like some sort of extensive 1,000-line bootstrapping process, you always have liveliness probes that can mitigate any sort of risk of the bootstrapping process not being done by the time something's scheduled there. So we talked about anti-malware. We're going to take a brief chance to do a demo to break up some of this presentation. So we'll be demoing from the Azure Cloud Shell. This is because oftentimes, if you're a Windows user and you have a Windows subsystem for Linux, it works great. But if you're like me, you're sometimes forgetful to update all your packages. Cloud Shell is very useful in that regard.
Yep.
So I've already deployed the daemon set. So as we'll see, so we have the antivirus here. All right, we'll exec into this container. And now what we're going to do is verify that the software is there both in etc on the underlying node and in initd. So we'll change to the mount. And then, so now we're in the underlying node, which you can see here. Now we'll change to etc on the underlying node. We'll do a dir. And as you can see, we have clamav installed here from the daemon set. Once again, we'll change into initd now. And to verify that it's here as well, we'll do an ls. And you can see we got clamav fresh clam. And so this is just really to show how to verify the solution is successful when implementing these more custom configurations in managed Kubernetes service. And this is being tested on AKS. So switching back.
All right, so obviously, now we're done with the security angle. Monitoring is something that's very important. Over here, how many of you guys working with customers, either work for customers or with customers that use, say, Splunk as a monitoring solution? Yeah, very, very popular. Obviously, Splunk is very popular. So we wanted to show an example. We wanted to show an example of how you could use Splunk to monitor your containers. And it's really easy. It's done through this daemon set there's a container image out there on Docker Hub that Splunk has put out. And all you have to do is to run it as a daemon set. As Daniel said, every node is going to get one instance of the daemon set. It's going to grab all the container logs and ship it out to the Splunk server for indexing so that it's easy for you to track it. One thing that applications should do, though, can you go back for the previous slide, please, Daniel? One thing applications should do is to write to standard out, because that way the logs will automatically be captured into Splunk without much ado. Yes. And so here's a good example of how that. This is the boilerplate Splunk daemon set configuration, and for the universal forwarder. And the main point in the red there is where you mount to the root node and grab all the container logs and scan them and ship them out to the Splunk server.
Yeah, and while this example is specific to Splunk, it also is applicable to any sort of custom monitoring solution that you may have to develop in-house based off of in-house tools. On every node within Kubernetes, by default, all logs are going to be logged to var lib docker containers, meaning that so long as you have access to mount that path, all you need to do is create a container that is capable of forwarding those to some sort of server and having the server being able to ingest these logs in the form of just .log files. So while it's specific to Splunk, if you have an in-house tool, just so long as you're able to mount this underlying location of the logs, you should be good to go. So another topic when it comes to monitoring is log rolling. So when it comes to monitoring, the best practice is usually more is better, meaning that you want to have verbose logging to ensure that you can retrace when something goes wrong, if it goes wrong, as well as to better understand the functionality within the cluster. Now, what this means is that oftentimes there can be bloat to the clusters if you have verbose logging for a lot of containers that exist on there. Managed Kubernetes services typically do have defaults for log rolling. However, there may be custom enterprise requirements to configure some sort of custom behavior for log rolling, or there may be a situation where you're finding performance impacts because of the size of logs given the volume of what you're scheduling on a particular node. In general, though, what we're going to show you is a daemon set that is a modification of the anti-malware example that runs as a pod with software installed that makes a change to an underlying node, meaning that it doesn't, it's not a process running on the node itself, but rather a container with access to the underlying node. So the callouts here, this is just a simple Nginx image, I believe, that I pulled, installed, log rotate on. Simple as that. The real magic here, though, is in the args once again. what we're doing is we're going to the mounted root here, the /mnt/root node, and then to the location of the containers, /lib docker containers, **.log. Then we're configuring some sort of custom behavior. If you're familiar with log rotate, it's as simple as just writing out that path, or writing out that file in some sort of printf. And so what we do is we schedule to roll all of the logs every week and not to keep any of the old logs. Maybe if we're working in an environment where we're getting like gigs of logs, I wouldn't know when that would be, but it's a good situation to customize. And then what you'll do is you'll create some sort of log rotate config name that can be set in the environment variables. And once again, we're doing the while true, do sleep, 30, done, to keep this process alive so it can continue to run. And so this is a modification from the anti-malware daemon set in the sense that, once again, it's installed on the pod affecting the underlying node, whereas anti-malware, as you can imagine, needs to have visibility to all of the containers running on a particular node, justifying the difference. So this would be an example where you might use more commonly, whereas the anti-malware would be a situation where in important situations you would use. So we're going to shift from monitoring now over to some of the synergy that comes with managed services.
Yeah, so we talked about, we've been talking about using managed Kubernetes service, but let's not forget that Kubernetes relies on other things as well, right? The most common thing it relies on is a container registry service. And so we recommend that you also use a managed container registry service as well, and not spin up your own VM and install all the software there. Same thing with databases that your application needs, right? Make sure you use just managed Kubernetes, SQL or NoSQL databases, MongoDB, whatever it is. There's a whole bunch of, all the cloud vendors have a managed service that you could just pay for. And same with file shares and storage. So just kind of the message over here is use managed services across the board. And don't forget about the other things that you also use as part of your Kubernetes cluster.
Yeah, essentially, if you have company buy-in to adopt managed services when it comes to Kubernetes itself, you also ought to be have that buy-in across the board when it comes to your technology stack in regards to lowering that administrative overhead associated with some applications.
All right, so we've been mentioning a little bit about these startup scripts, and essentially they're just shell scripts that can do a whole bunch of things. We've got some use cases over here. We've covered some use cases already, and there are some additional ones over here. For example, you may want to set the time zone or set up custom host file settings on the pod as you run. And the way that it works is you kind of plug this into the application startup process. Today, when you create a Docker container, you just go into your application and you run your application. What we're saying over here is before that, you have an extra step, which is a bunch of scripts that essentially customizes it for your environment. So Dan, if you go to the next slide.
Or one more thing there is that the biggest thing that you want from a DevOps perspective is to be able to change parts of the DevOps process while affecting as minimal of the stack as possible. Meaning that applying startup scripts when it comes to the runtime of the containers has unique value in that you don't have to rebuild all of your containers across the board every time you update your standards. But rather, you can do so in some sort of single point, and you won't have to replicate that effort across the board for your application.
Yes. And this also ensures that the applications have no options. When they run in production, they're going to have all these whether they like it or not, because you're controlling the startup script process. And so essentially, you could write a small shell script that all it does is goes to blob storage, it downloads an actual bigger script, runs all the commands, and finally says, okay, hand over control to the application, and that's it. But by then, everything's been set up exactly the way that the enterprise customer wants it to.
Yep.
And of course, if you would use Kubernetes secrets to store the location of these shell scripts, that's just normal best practice. There's a couple of other topics we wanted to talk about. We've kind of covered most of the important ones, but there's two additional kind of future topics that I want to discuss real quick. One is we're seeing an increased importance excitement about serverless. As you know, in a Kubernetes cluster, typically you have static nodes. And these days, everybody is like, do I really need static nodes? Can I get something more on demand? Yes, you could, Kubernetes clusters can scale up and scale down, but we all know that takes a little bit of time. The scaling up process is not instantaneous. And so by using the new virtual node or the virtual kubelet feature in the Kubernetes spec, in the recent version of Kubernetes, any cloud vendor can plug into that process and provide their own definition of what a node is, okay? A node doesn't have to be a physical thing. It can be a virtual thing. And that virtual thing can point to, for example, like a Fargate environment in Amazon or ACI Azure Container Instances. I forget what the Google one is called, but yeah, they all have these dynamic container services that you can that essentially meant just to run a quick container and then tear it down, right? You build by the second, and but it's just very quick in and out. And the virtual kubelet allows you to plug in Kubernetes into that feature such that you don't have to do anything. You just have to create a pod, just like you do normally. Create a deployment, ship it out, and it will just use the the virtual node. And if we have time, we'll show you a demo later. But that's something that I definitely recommend you guys look at. The second one is, which we're seeing a lot in enterprises, is they typically have a lot of file shares already that they're using. Maybe they've got other third-party applications from on-prem that are writing to the file shares, and those file shares have to be made available to the pod that's running in Kubernetes. And so in Kubernetes, you can set up a mount to a SMB share. But again, like I mentioned earlier, make sure that you use a managed service for the file share. And so, all the cloud providers provide managed file shares. So I would recommend you use that and then connect your pod to the file share. And we've got a couple of quick YAML files for you to see over here. This is how you do the virtual node setup. Again, this is possible with AKS, and we have it working in Azure Container Service, so it's something you can do in a managed Kubernetes environment. You don't have to muck around with the underlying infrastructure to do this. The second one, Daniel, if you can scroll up to, this is the YAML file for the file share service, and nothing but just mapping, mounting a drive to the file share. It's just baked into the YAML. You'll notice we're just using kube control for everything. We don't really want to muck around with the underlying infrastructure. That's really the story over here.
Yeah, when it comes to the file share, what you'll see when you're defining the volume is that there's native support to define an Azure file, and then you just provide the secret name and the share name in order to access that. So what we're seeing is more and more integration with upstream YAML support for Kubernetes when it comes to cloud provider-specific functionality. And oftentimes this is replicated across multiple types of clouds. All right, so we've already gone through the anti-malware demo. Next, we're going to jump into, really briefly, the log rotate demo, and then we'll close on Splunk and potentially serverless if time allows. So let's exit out of this container.
And while Daniel's setting that up, does this resonate with folks over here in the, do you guys see this with your enterprises, what we're talking about here? Is this something that makes sense? Is there anything that you think that we're, that you're dealing with that we may not have covered over here? Any specific topics that you think that you're pressing at your customers, especially enterprise customers? Yes? Container hardening, you said? The hardening of the actual container, yeah. You mean so before image, hardening the image itself, right? Scanning the image. That's yeah. Companies like Twistlock and whatnot are offering. Are offering. Definitely. That's a very good one. Yes, Vishwas? Patching of the nodes. Yeah, that's a good one. So one of the things with the managed services that the cloud vendor will typically apply patches to the nodes. But what they do is they don't reboot the nodes, because rebooting a Kubernetes node is very disruptive. And so they'll patch the node and they'll give you a flag, a set of flag for you to reboot it on your schedule. And so customers have to do that on their own schedule. They would have to do the cordon and the drain of the node, reboot the node, and then uncoordinate again. So that's something they would do like on a weekend, off hours. But you can do it in a managed way, in a controlled way, I should say, such that you don't impact any of the pods that are running on those nodes. And you do it, obviously, one node at a time.
Great. So to jump back into log rotate, thank you for everyone for that. So as you remember, we have the args here, which is really doing the bulk of the work. We're defining that where we should be rotating logs is on the underlying node. However, the application itself is being run from the pod. So what we'll do is kubectl get pods. We'll exec in. And so we're going to navigate to, on the pod itself, the etc, and then log rotate D. So we see here we have AKS logs, which is how we defined it in the environment variable for that tool. We'll cat AKS logs. And what we can see is that we have this behavior injected into the log rotate tool from a pod, being able to customize that underlying node behavior. So I'm going to hand it off to Sujit now.
I'm just going to grab your HDMI cable real quick. Got a quick thing to show you guys. I know we're running out of time here. Let's see, wait for my screen to come up here. Yeah, okay, great. So I have a couple of Kubernetes clusters over here that are set up. So as you can see, we've got a bunch of pods running. Of course, the Splunk pod, and got a log rotate, everything, antivirus is all here. But the important one I want to show, the first two are the ones that are the standard UI and middle tier deployments that we put out there. So let's see. You guys have all seen Splunk, be familiar. This is a standard Splunk setup. So let's run the application real quick, and you can see like from the services that there was an external IP assigned. I know I use an external IP, although we said not to use an external IP, use an internal load balancer. It's just easier to demo an external IP, so forgive me for that. So anyway, so we're going to use that external IP to just to fire off a quick app over here, and I don't know what happened there, but okay, we're going to hit that app over there. And over here, I'm going to just say ASP.NET Core, for example. We're going to say look for all events over the last 1 minute, right? And so as this thing runs, you'll see that it's very quickly it's able to all the events are flowing from the Kubernetes cluster into Splunk, and you can quickly track it. As in this particular case, Daniel, we have to go and take a look at this because I see a lot of exceptions over here, so there's something going on. But yeah, you can go in and take a, that's one thing that it's good for. Yeah, so I think we're a wrap on time. How are we doing on time?
Yep.
Okay, we'll take a few more. We've got a few minutes for questions, so why don't we save some of that last few seconds for questions? So happy to take some if anybody has. Question over here.
I'm curious about the feasibility of a large centralized Kubernetes cluster that can cater to multiple applications in an enterprise organization.
Yeah.
Yeah.
Any special concerns that come up?
Let's repeat the question, Daniel, and I think you have some expertise on that. Go ahead.
So the question is concerns about running multiple large applications on a single Kubernetes cluster, managed cluster in the enterprise. It's a really good question. It's something that a lot of companies are having to play around with to decide what works best with them. Generally speaking, what managed Kubernetes services do, at least in the context of AKS, is it provides a free control plane. This means that it really lowers the overhead associated with having multiple clusters. And so what we're seeing is that the standard practice when it comes to hosting production workloads is to have the particular application hosted on a cluster of its own. Typically then that cluster, there are multiple replicas of that cluster across different time zones as well. For testing environments, it oftentimes makes sense maybe to just have non-load bearing applications resting on the same cluster. However, just with the cost minimization associated with the free control plane, there isn't that overhead that you would typically have when introducing a new cluster with new master nodes.
And
Does that make sense?
You've worked with some customers that have really large number of nodes, right? How many nodes are we talking about here?
So currently I'm working with a customer in a scenario where there's like over 500 containers at rest across 20 nodes. And so when you have these large applications already at rest, you want to ensure that no process-hungry elements of application 1 can impact any sort of have any impact on application 2. Because that can lead to some confusing troubleshooting, we'll say.
Good question. Any other questions over here? Back, yes. Yeah, yeah. We've never set the good question. So the question is, if you have a multi-tenanted cluster, can you split the logs into different Splunk servers, right? Is that what your question? Or different indexes, at least, in the same Splunk server? I know what you're talking about. we've not actually tried that out. It's a good question, but I believe that the Splunk configuration. I was looking at the YAML file, and there is a setup for the JSON that you can do inside of Splunk before you index it through this forwarder from the containers. And there's some setup you can do over there to maybe achieve what you're talking about. But yeah, I think that may be possible. Good question. Anything else? Go ahead. No, you're up, Vishwas. Go ahead.
So the question there was that, you want to set up multi-tenant server, and the answer was the code very free.
Well,
If I want a truly high-density cluster, then can I rely on the group policies and things like that to have the network segmentation that will allow me to multi-tenant?
Good question. Yes. So what the point is, which I was making is, can you, when you have a large number of pods and nodes, can you use something like network policies to control, who has, how things are bucketed, who has access to what? And for sure, that's one thing that we're looking forward to. I believe KubeRouter and Calico are coming to the managed Kubernetes service. They're available in your, bring your own when you make your own Kubernetes cluster. But our focus is more on the managed side, and so we're waiting for those things to come in, and they are going to be coming in soon. Once those network policies are in place, we'll be able to apply labels to all these pods and say, okay, pods that have this label can only talk to pods that have that label, and so on and so forth. And so you can start enforcing a zoning layer inside of your Kubernetes, because Kubernetes tends to be very flat. Yes, you have namespaces that you can use in some way, but generally tends to be very flat. All the pods are very flat. So by using these network policies and labels, you can effectively control who has what, access to what, and segment the traffic accordingly.
Perfect. Thank you.
Great question, though.
And I think that is time. Thank y'all so much for coming today to discuss.
We'll be around here for a little bit if you guys have any questions.
Come up if you have any additional questions or want to talk further about